So we're looking at rewriting rational exponents to radical form right here. So we're going to take a look at, this is just continuing on from what we did in the previous video on exponent rules review. Right here, the key idea is that we're building up, we've been building up from our three basic rules, our product rule, quotient rule, and power of a power rule, and now we're going to look at our radical rule. So essentially our radical rule is the next logical step from our product, quotient, and power of a power rule, because in the product rule we added the exponents, in the quotient rule we subtracted the exponents, in the power of a power rule we multiplied the exponents, and so we see here a fraction is just a division of exponents, right? So we'll go into that a little bit more later on. So the easiest way to kind of get a grasp of this to start with is just by looking right here at our x to the half power, right? You may or may not be familiar with the idea that x to the half power is equal to the second root, or the second root, we don't say the second root, we just say the square root of x to the power of 1. Okay, now this is an odd way of showing this. It's a very odd way of showing this. Normally, we would just see this as the square root of x, right? So you may be familiar with this. You may be familiar with this idea, okay? But hopefully you see the general, what's going on here is that our denominator from our fraction is coming from what we call the index of the radical, and our numerator in the fraction is coming from the exponent that the radicand is raised to. Right, more on the vocabulary is right over here. We'll talk about that in a moment. So with that in mind, we're going to look at these examples here. We see that if we've got x to the 6/5 power, we can take the denominator and say that that's the index of our radical, and we've got x to the 6th power on the inside. Useful so far. Same idea with x to the 3/4, right? That means we've got the 4th root of x to the 3rd power. Now, it's worthwhile noting that you can also write these as the 5th root of x and put parentheses around it and raise it to the 6th power. Same with this idea here. You can say it's the 4th root of x and raise it to the 3rd power. And we've got to be careful with that, though, and I'll show you why in just a moment. Let's take a look over here, and it might clarify for us. See this 2x here? We're raising that. We're putting that into a radical. It's the 4th root of 2x, and we're raising all of that to the 3rd power. Okay, and there's a reason why I'm writing it like this. I'm writing the whole 2x raised to the 4th root of 2x raised to the 3rd power. I could also, however, write this as the 4th root, watch my parentheses, of 2x to the 3rd power, right? This is okay because, look, the exponent of 3 distributes, if you like. That's that's your product to a power rule, right? It distributes in, and then you get 8x cubed. So it is okay to write this as the 4th root of 8x cubed and remove the parentheses. But you should be very, very careful that you don't write this because it's not equal to the 4th root of 2x to the 3rd power. Be careful with that, right? Parentheses really do matter. Okay, going into a little bit of vocabulary, and then we'll reverse the process. So the vocabulary we're looking at here, take a look on the right-hand side here. We've got on the outside of the radical, we call it a radical, not a square root symbol. Square root is too specific. It's specifically for square roots. So the radical covers all kinds of roots like that. The index is the index of the root, so whether it's a square root or a cube root or a 4th root or whatever, right? And our exponent is still an exponent, and it's the exponent power of the radicand. The radicand is what goes underneath the radical, right? And you're already familiar with what a numerator and a denominator or a fraction are. Okay, and the other thing that I kind of pointed out in the examples above, it's okay to write the exponent on the inside or on the outside. Just watch out for those parentheses. All right, so here's our general rule right here. You could write it one way or the other. This is the division part that we were missing from our 3 original rules. And this is what it's about. This is what it's all about. Okay? So we can rewrite from radical form to rational form, and this is probably more useful because it's easier to calculate when we've got it in rational form, right? So to do this, what we do is we take the radicand, which in this case is 2x, and we raise that whole thing to the power of a fraction. So our denominator of a fraction is in the index. So we must note here that all of this is raised to the power of 1. So it's raised to the power of 1 over 5. So the 5 being the index of the radical. Okay. Watch our parentheses here again. And watch also, this is a square root, which means that there's a 2 that we don't see. Right? So this means here that we actually have x to the power of 3 over 2. And a cool thing here is that we can actually simplify these things. So in this case here, where we simplify to x to the 6 over 3, notice that that 6 over 3 simplifies to be x squared. Okay, so the third root of x to the 6 is just a complicated way of writing x squared. Another thing to note is that our rule, where if you remember when you were studying square roots, you had the square root of a product is a product of the square roots, right? If you might remember that phrase, generally it works the same way. So we can actually look at this by breaking up all of this product inside the radical, and we can say that this is equal to, so we can say this here is equal to the cube root of 7 times the cube root of x to the 6 times the cube root of y to the 8th, right? So we can break that up. This is the same kind of idea as that square root of a product is the product of the square roots that you might have heard during studying square roots. Okay, but this means that each part can be dealt with separately, and so it's quite easy to say that this is 7 to the 1/3 times x squared, we dealt with that right up here, times y to the 8 over 3. And that's how we would, you don't need that multiplication symbol right there at the end. You can just put 8 over 3 like that. Okay, so that's how you would deal with that. Okay, moving on, I'd like to go over a few more examples, and as we are, so we're going to rewrite between forms. These are the examples that you might see on your worksheet. So we're going to rewrite between forms. I'm going to zoom out just a little bit so that I can see this a little bit better. So we're going to rewrite between forms. Before we do, just a quick note on your fraction operations. If you pause the video for a second and take a look at these and see that you're familiar with them. If you're not familiar with them, go back and learn them because these are essential. Okay, back to where we got our rewriting from rational to radical. Okay, some simple ones to start with. Okay, so the n to the 4/11, well, that's the denominator, the 11th root of n to the 4th power. That's straightforward so far. Okay, watch your parentheses. We've got the 8th root of 5n. We don't need to worry about the parentheses now because our exponent power is 1, so we're ignoring it. I'll come back to the challenge in just a second. All right, let's take a look at going from radical to rational. Recognize there's a 2 here, and so therefore this must be m to the 9 over 2. Okay, our 2 is our denominator, our 9 is our numerator. Watch out here, the 5 is not affected by the 4, right? By the exponent of 4. So essentially this is something that's broken up. This is the 7th root of 5 times the 7th root of m to the 4. Okay? And so we actually have 5 to the 1/7 times m to the 4/7. Right? So watch out, those parentheses really do matter. And something like this is quite, it looks complicated, but it ends up being quite simple. The 4th root of 81 is 3. So the 4th root of m to the 16 is m to the 16 over 4. Well, 16 over 4, 16 divided by 4 is just 4. And then m to the 40 divided by 4, or n to the 40 divided by 4, 40 divided by 4 is 10. right? So that simplifies quite easily. And again, an exercising watching out for the parentheses right over here. This gives us 11m, and watch out, the parentheses are 7 over 8, right? So the 8th root, so our denominator is 8. If you left it without parentheses, then you missed out putting the exponent 7 over 8 into the 11 as well. So that's where we're going to leave this. All right, we'll catch it up again in the next video on applying exponent rules to rational exponents.